Welcome to Wings of Aero, Advanced Education and Research Organization. Visit our website www.wingsofaero.in.
Hi friends, today we will see a few solved questions on theory of vibration which has been asked in GATE 2019. First question, in the spring mass system shown in the figure, mass M equals to 3 kg and spring stiffness K equals to 20 kilonewton per meter. The natural frequency of the system is dash hertz. We need to find the answer in round off to the nearest integers. So let's see the solutions. We can see the figure. This figure can be resolved. This to k value is in series. So this we can find using 1 by k equivalent equals to 1 by k plus 1 by k. So we can get the answer of this equivalent of the spring system. K equivalent equals to k by 2. Now we got this. Now we need to resolve this function, and this is acting as a system of parallel concept. So we can also find this entire spring system of this. We can get an entire equivalent equation, that is k by 2 plus k. We get as 3k by 2, and we substitute the value of k which has been given in the question. Now in the question they have asked the natural frequency in terms of hertz. So this is the formula, that is omega by 2 pi. Now what is omega? Omega means root over k equivalent by mass. Now we know the equivalent value from this equation. Mass already been given in the question, and we get the result as omega 100 radian per second, and this value has to substitute in this previous equation. Now F equals to 100 by 2 pi equals to 15.92 hertz, and they have asked in the round of integers, so which is equals to 16 hertz. So right answer is 16. Next question, for a damped spring mass system, mass M equals to 100 kg and stiffness K equals to 100 cube Newton per meter, and damping coefficient C equals to 20 kg per second. The ratio of amplitude of oscillation of the first cycle to that of the fifth cycle is, round off to 1 decimal place. So what are the given data? First we'll clarify that. This mass 10 kg, stiffness K equals to 10 power 3 Newton per meter, and the damping coefficient C equals to 20 kg per second. Now we need to find the ratios of amplitude of oscillation, that is x1 by x5. So let's see the solutions. First we need to find the damping coefficient, critical damping coefficient. So we can find using this formula 2 by root over k into m. So we substitute the values of k and substitute the value of m, and we get as 200 kg per second. And after that, substituting the values in the damping ratio, tau equals to C by C suffix C. We got this value and we get the damping ratio as 0.1. Next, recalling the formula logarithmic discriminant, that is del equals to 2 pi tau by root over 1 minus tau square. Now substitute the values of tau in this respective formula. We get the del equals to 0.6311. Now similarly we are recalling the similar conditions of logarithmic discriminant, that is del equals to 1 by n ln x1 by x5. So here the n value will be 4. So this is the formula for this first cycle to that of fifth cycle. Now substitute the value of del here, and we know the respective values. By simplifying we get that x1 by x5 equals to 12.4. So our answer ranges from 12.3 to 12.6. Next question. For the system of spring and masses shown below, K equals to 1250 Newton per meter and mass equals to 10 kg. The highest natural frequency omega of the system is radian per second. Round off to the nearest integers. So here you can see the figure which is displayed on your screen. Here we will see the solutions. Here are the given datas, that is mass is given and K value is given. Here you note down, here is a displacement for this mass 1 and here is a displacement for the mass 2. Here mass 1 and mass 2 are same. And here K1, K2 and this K3. Here K1 equals to K3 and K2 equals to twice of K. So let's see the solutions. So using this, first we will find the free body diagram of mass 1. When we want to draw the free body diagram of mass 1, we can write that mx double dot of 1 plus here the force of this spring and then the force of this. When we want to find the force of this spring, this spring is connected with two displacement. So when you are finding the mass with respect to mass 1, so we will write the displacement as x1 minus x2, which is equal to 0. Now comes when we are finding the free body diagram for mass 2. Here first its displacement for this mass 2, then comes here this spring K2 spring. Here the K2 value is 2K, where it is finding with respect to the body 2 with the body 1. So we can write x2 minus x1 plus this is the K3 value. K3 value equals to K with respect to x2. So K into x2 equal to 0. Now we need to know what is x1 and x2. x1 is equivalent to a1 of sine omega t, and if we want to find that is x double dot of 1, we need to differentiate twice and we get at minus a1 omega sine omega t. Similarly for x2 equals to a2 sine omega 2, and when we double differentiate this equation, we get as x double dot 2 equals to a2 minus a2 omega sine omega t. Now what we are going to do is we are simply going to substitute these values in this above equation. After we substitute this in above equation, we get the simplified equation as k plus 2k minus m omega square of a1 minus 2500 a2. Now similarly for the second equation, when you substitute the values in the second equation, you get this, that is minus of 2500 a1 plus k plus 2k minus m omega square into a2. Now these equations can be converted in characteristics equation, which in terms of determinant equal to 0. Now simplifying this equation, like substituting the value of k. We know the value of k is 1250 and m value is 100. Substituting here, we get these values. Now what we are going to do, we are going to make an characteristic equation. So we are going to multiply this into this minus of this into this, and we get this equation. And for the simplification, we get that omega power 4 minus 750 of omega square plus 78125 equal to 0. Now using quadratic equation, we are going to solve this. Solve what? We are going to solve this omega square. Omega square equals to minus b plus and minus root over b square minus 4ac by 2a. Using this formula, we will substitute the b value is minus of 750. Here also b value 4, a value is 1 and c value is 78125 divided by 2 into 1. Now we simplify and we'll get two values. 1 in 1 root is omega 1 equals to root over of this value, where we are getting as 11.2 radian per second. The second root we are getting as at 25 radian per second. In the given question, they have asked the highest natural frequency in radian per second. So our right answer is answer 25.